an American experimental physicist, honored with the Nobel Prize for Physics in 1923 for the measurement of elementary electric charge and for his work on the photoelectric effect. He was born on March 22, 1868 in Morrison, Illinois, and he died on December 19, 1953 in San Marino, California.
He's the best known for discovering the charge of the electron, the photoelectric effect, and cosmic ray physics.
The experiment was called the oil drop experiment, and it was performed in 1909 by Robert Millikan and his assistant Harvey Fletcher. The purpose of this was to measure the elementary electric charge, the charge of the electron.
Elementary charge, the electric charge carried by a single proton, or equivalently, the magnitude of the electric charge carried by a single electron. Coulomb, the unit of electric charge equal to the quantity of electricity conveyed, I don't know how to say that, in 1 second by a current of 1 ampere. Newtons per Coulomb. Sometimes scientists describe electric field strength in newtons per coulomb of charge. Electric field, a region around a charged particle or object within which a force would be exerted on other charged particles or objects.
Starting in 1908, while a professor at the University of Chicago, Millikan, with a significant input of Fletcher, and after moving his setup, published his study in 1913.
Lab equipment used: a box, a microscope, a set of plates, and perfume spritzer.
The box housed the experiment. The metal plates were set up inside the box, both horizontal and parallel to each other. Then an electric potential difference, or voltage, must be applied across the plate, and the space between the plates will then be permeated with an electric field. Using this, Millikan was able to measure and adjust the voltage and the field between the plates very precisely. On one side of the two plates, Millikan placed a microscope. On the other, a perfume spritzer. He spritzed drops of oil through the nozzle and they picked up a negative charge. The droplets were affected by gravity, just like anything else, and fell downwards towards the bottom of the plate. If Millikan adjusted the field just so, he could make the drops hover or even rise. Millikan knew that different oil drops contained different amounts of spare electrons. He had no way to measure the amount of electrons on the drop, but that didn't matter. The amount of force required to keep a drop in the air was always a multiple of a certain number, and that number was the charge of the electron.
This was a brilliant experiment, and Millikan knew it. He said, "One who has seen this experiment has seen the electron," and the rest of the scientific community agreed. The oil drop experiment provided a measurement of the charge of an electron that is comparable to today's estimates. In 60 days, with 58 drops and no single drop being omitted, Millikan had measured the charge of the electron. Decades later, when people went over the records, it seemed that a few drops had been omitted. In fact, 115 drops had been omitted because they varied away from Millikan's expected value from the charge of an electron and towards the value that Millikan's scientific rival Felix predicted from the electron. Since this discovery, Millikan's experiment has come into dispute. While no one can dispute that Millikan's predictions were accurate and that the experiment works, the concilied conflicting data has turned the oil drop experiment into a famous case of misconduct. Some people even call it a fraud.